Our next lesson on binomial expansion is another way to use our calculator to find terms of the binomial expansion using the binomial theorem. So what we need to do is locate on our calculator what we call n choose r, okay? And that is actually this formula. Now, if you have a TI-83, I would Google it and figure out where it is. On an 84 or 84 plus, it is under the math menu under PROB is where you're going to go, probability. And it's number 3, N choose R. And on the new calculators, when you press this, number 3, it actually gives you this and then a C and then another box, and those numbers are specifically found right here in our formula. So 7 choose R, if we do the first one, and all you have to do is hit second enter each time on these problems to figure out the next number, the next coefficient. Rather than having to go through and draw the Pascal's triangle now, we can just find the specific term we're looking for, the coefficient of the specific term. So I'm going to use n choose r. So I'm going to go to math probability. I'm going to go to number 3, and I'm going to hit enter. So then I'm going to hit 7 in the first open box and then 0. So it should look like this on my calculator. Well, 7 choose 0 is 1, what we would expect. We would expect 7 choose 1 to be 7. So second entry, go over to the 0 and make it a 1, you'll get a 7. Now, second entry, what's 7 choose 2? 21. So the third coefficient is 21. So 7 choose 3 is 35. Okay, 7 choose 4. Again, all you do is hit second entry and overwrite the last one. 7 choose 4 is 35. Okay, so you can see the pattern. It'll be 21, 7, and 1. So comparing that to Pascal's triangle, 1, 7, 21, 35, 35, 21, 7, 1, it is the exact same thing. So using this notation right here, 7 choose 7, 7 choose 6, 7 choose 5, that is called a combination, okay, is the proper terminology here. But what we can do is we can find any term, okay, any term knowing this and then whatever our given part is. And this stuff is really important, but I think it's easier just to go to a problem. So we're going to find the 7th term of a plus b to the 30th. So that would be 30 choose. Now, if it's a 7th term, remember the first one is 0. Choose 0. So the 7th term would be choose 6. Now, here's what's important. The lower value of the coefficient matches the exponent of the second term. So this would be a, and then b would be to the 6th. And I would know that because these two numbers match, okay? But that also means that these have to add up to 30, so a is 24. So now I put in 30 choose 6, ooh, it's going to be a big number, is 593,775, a to the 24th, b to the 6th. That is the 7th term of our expansion. That would be tough to do using our old method, our other method, okay? The next one says, hey, find the term that contains x to the 5th in the expansion of 2x plus y to the 20th. Ooh, boy. How are we going to find? Well, we know that it's going to be 2x to the 5th, correct? Has to be. Has to be 2x to the 5th to get x to the 5th. But that also means that that's got to be y to the 15th because it has to add up to 20, which means it's 20 choose 15 because I know these two numbers always match. So 20 choose 15 is manageable. That's 15,504. 2 to the 5th, isn't that 32? Times 32, x to the 5th, y to the 15th. So we got to take 15,504 times 32. And the x to the 5th would be 496,128, x to the 5th, y to the 15th. That it would be the 6th term. No, it'd be the 16th term, I believe. 14th term. At any rate, that's x to the 5th. Interesting stuff. Now, worksheet number 2 is very similar to what we just did here. This one and this one. So I'm going to pick one of these specifically, and I think I'm going to do this one just for the heck of it. Find y to the 8th in the expansion 2x plus y to the 12th. Okay, so I know that it's y to the 8th, right? So I know it's got to add up to 12, so that's got to be 2x to the 4th. I also know that it's 12 choose 8 because these two have to match. So I'm going to do 12 choose 8. So math, PRB, number 3, 12, choose 8 is 495 times 2 to the 4th. I think that's 2 times 2 is 16. X to the 4th, y to the 8th. And so that would be 495 times 16. And we have 7920 x to the 4th, y to the 8th. That would be the term that has y to the 8th. So I hope you have fun with it. It's quite interesting. Do the best you can and ask questions.